this. If I look at this next one looks like it's going to be pretty simple because I'm looking at these and I see a negative y and a positive 2y right off the bat. So I know that to do this one, all I'm going to have to do is multiply this first equation by a 2. Whatever I do to one side, I have to do the other side. So that first equation is going to become a negative 2y plus 4x equals a negative 8. And again, I'm going to rewrite this second equation down here so you can see it a little better. 2y minus 4x equals 6. Now I have additive inverses, so I'm going to go ahead and add these two together. And when I do that, negative 2y plus 2y is 0. 4x plus a negative 4x, that's also 0, so I'm left with a 0 over here. And then negative 8 plus 6 is a negative 2. And does 0 equal a negative 2? No, that's ridiculous. 0 will never equal a negative 2, not on this planet. So since that's not a true statement, that's not a true story, Mr. Jansen, I'm going to say this one's no solution. Okay? And that's the difference, all right, between infinite solutions and no solution. If I get a true statement, it's infinite solutions. A false statement like this one, it's no solution. Okay? If I look at these next two, it's method of your choice. Oh, boy. I love it when I have a choice to make. Okay, so solve by the method of your choice. If I look at this first one, the obvious choice here, I'm going to go with the obvious choice. Okay, you don't have to go with the obvious choice, but I'm going to go with the obvious choice. If I look at this one, the first equation is already solved for y. See, y equals a negative 2x plus 6. So I'm going to use substitution because it's already solved. I'm going to plug that in for y in the next equation. So that means I'm going to have 3x minus 2 times y, but instead of y, I use the negative 2x plus 6. And this was set up really well for substitutions. That's what I'm using. And now I'm going to distribute the 2, or the negative 2, rather. So that's a 3x plus 4x minus 12 equals 16. Combine some like terms here. The 3x and the negative 4x. Sorry, that's a plus. That is a plus. I can't even read my own handwriting. That is an issue, isn't it? Let me try again. I can't live with that, Mr. Jansen. Let's try again. Oh, yeah, now it looks like a plus sign. Now I can read it. So when I add those together, that's going to be a 7x. So I have 7x minus 12 equals 16. I've got to add the 12 to each side. So I find out that 7x equals a 28. I've got to divide each side by 7. So I find out that x equals 4. But I'm not done yet. I've got to plug that back in. So I've got y equals negative 2 times x, which was the 4, plus 6. So I've got y equals a negative 8 plus 6. So it turns out that y equals a negative 2. So my ordered pair here, I wish I had a little more room. Hooray, now I have more room. Is a 4 comma negative 2. Okay, so that's my solution. All right, if I look at the next one, the obvious choice here. It's so obvious. It hurts how obvious it is. I've got a negative 2y and a positive 2y. So this is set up. Everything's lined up for elimination. It looks great. So I'm going to use elimination. Okay, I'm going to add these two together. So let's see. 2x plus 3x is a 5x. Negative 2y plus 2y is 0. Negative 5 plus 1 is a negative 4. And I'm just going to solve this for x. I divide each side by 5. So x equals a negative 4/5. And don't freak out because it's a fraction. It's okay that it's a fraction. We're allowed to have fractions. It's cool. All right, they're numbers too. So I'm going to plug this back into one of them. So I'm going to take the first equation. I'm going to plug the negative 4/5 back in. And I'm going to solve it for y. So let's see. That's going to be a negative 8/5 minus 2y equals a negative 5. And if you don't want to get common denominators here and deal with fractions as much, here's my recommendation, because I've seen a lot of people struggle with this. Let's just get rid of the fraction. I'm going to multiply through by 5. Okay? And when I do that, I distribute, so that's going to give me a negative 8 minus 10y equals a negative 25. And now at least I don't have to deal with the fractions anymore. So I'm going to add the 8 to each side. So let's see, that's going to give me a negative 10y equals a negative 17. Now I've got to divide each side by a negative 10. And I find out that x equals 17 over 10, a positive 17 over 10. So my ordered pair here, 17 over 10, comma, negative 4/5. Hooray! Okay? And again, don't be scared of fractions. Fractions are okay. They're numbers too. All right? Don't discriminate against fractions. All right? If we look at this next one, oh, this is a great problem. This is so much fun. Okay? You solve using all three methods, then explain which method is best. So we have to do all three methods, then we can explain which method is best. So, if I look at this first one, the first equation's already set up for graphing. That's great. The second one is not so much. All right? The second one, we're going to have to solve for y in order to put it in graphing form. So let me select a pen. Oh, yeah, that would work better, Mr. Jansen. So negative x plus 1/2 y equals a negative 1. So I'm going to have to add the x to each side. So I get 1/2 y equals x minus 1. And now from here, in order to get rid of a 1/2, I'm going to have to multiply each side by 2. So that's going to give me y equals, over here I've got to distribute, so that's 2x minus 2. Okay? So now I can graph. I'm going to start with graphing this one. I've got a y-intercept of 3, so I go over my y-intercept 3. I slope of negative 2, down 2 over 1, down 2 over 1, down 2 over 1. And I draw my line. Oh boy, that is a nice looking line, Mr. Jansen. That's wonderful. Okay? And then I'm going to graph the other one. Let's see, that's a negative 2. Oh, that looks beautiful. And then up 2 over 1, up 2 over 1. All right, and that looks like that-ish. Boy, this is not looking very good. My lines are a little off. You know what I should have done? I should have used some appropriate lines. That's okay. These are pretty close. So now, if I look at that, this doesn't give me a real accurate depiction. Obviously, it's going to be a fraction. So graphing has kind of failed us. But I can visually see my solution here, which is going to help me to check these other ones. Okay? I guess I'll do elimination since it's listed over here. Yeah. So I'll do that one next. So let's do elimination. With elimination, I kind of have to have these things in order. I want to put them in almost standard form. So if I look at this first one, this first equation is almost in standard form. In fact, it's pretty okay the way it is. The negative x plus 1/2 y equals a negative 1. The only thing I would do is I would change this to get rid of the fractions. Okay, so I don't have to deal with the fractions. So I'm going to multiply through by 2. Okay. So now the equation I'm going to use here, that's a negative 2x plus y equals a negative 2. Now that looks nice. Okay. If I look at the other equation, the y equals negative 2x plus 3, I've got to get everything on the same side, so I'm going to add the 2x to each side. So that gives me 2x plus y equals 3. All right. So the two equations I'm going to use now that I've transformed these a little bit, there's one of them, and here's the other. So I'm going to line these up now that everything's going to fall into place. So I've got a negative 2x plus y equals a negative 2. And then the 2x plus y equals 3. And look at this. I already have additive inverses. That worked out pretty well. So I add these together. So that's negative 2x plus 2x is 0. Y plus y is 2y. And then over here, I've got a 1. Negative 2 plus 3 is 1. I've got to divide each side by 2. So I find out that y equals 1/2. But I'm not done yet. I've got to go back and plug this in to solve for x. All right. Now I can choose any one of these equations I want. All right. I'm going to use this second one right here that I created. See, that's 2x plus 1/2 equals 3. So if I subtract 1/2 from each side, and for this one, you could eliminate the fractions if you want. That's going to be a 2.5, which is 5/2. And then if you divide each side by 2, dividing by 2 is the same as multiplying by 1/2. So you're going to end up with x equals 5/4. Okay? Now, if that was a little bit tricky, let me do this one more time. For the folks at home, let's multiply through to eliminate the fractions to show you how easy this can be. If I multiply each side by 2, that's going to give me 4x plus 1 equals 6. Now it's much easier to do. Okay? See, dealing with the fractions, we're just asking to make mistakes. So we'll do it this way. I'll subtract the 1 from each side, so 4x equals 5. And then I've got to divide each side by the 4. And lo and behold, I get 5/4 again. Okay? So the ordered pair I got here was 5/4, comma, 1/2. Okay? And if I compare that to my graph, yeah, that looks like about where my graph is. 5/4 is like 1 1/4, and then up 1/2. So that's probably pretty close. Let's check it with substitution, because I do have to do substitution. What's nice about this one is substitution. This first equation is already solved for y, so I've just got to plug that in to my second equation. Okay? So let me plug it in. So I've got negative x plus 1/2 times y, but instead of y, I'm going to use the negative 2x plus 3 equals a negative 1. All right, and now I've got to solve this for x. So here with the 1/2, I've got to distribute the 1/2. So that's going to be a negative x minus x plus 3/2 equals a negative 1. Again, combine like terms. The x values over here, so that's going to be a negative 2x plus 3/2 equals a negative 1. And now from here, I could subtract the 3/2 from each side, but if you're concerned with these fractions, let's get rid of them. Don't deal with fractions. If you're worried about making a mistake, multiply each side by 2. So when I multiply each side by 2, that's going to be giving me a negative 4x plus 3 equals a negative 2. And now see how much simpler this is by getting rid of the fractions? All right, that one little extra step makes life a lot easier and gives us a lot more confidence. Yeah, I feel pretty confident, Mr. Jansen. So let's see, that's going to be a negative 5 over here. Subtract the 3 from each side. Now I got to divide each side by the negative 4. So I got x equals a positive 5/4. That is a very good sign because that's what I got with elimination. But I'm not done yet. I've got to plug this back in. Remember, y equals a negative 2x plus 3. So I'm going to use that equation, y equals a negative 2x plus 3. And I've got to plug the x value back in. So I've got a negative 2 times 5/4 plus 3. So that's y equals negative 5/2. Can't make anything easier. We could add the fractions together if you're comfortable doing that. If not, again, eliminate the fractions. It's cool. We can eliminate fractions anytime we want. Doesn't matter that there's no variables on the one side. Okay, so that's 2y equals, now this is going to give me a negative 5 plus 6 when I distribute that 2. And I combine like terms. 2y equals 1, divide each side by 2. Great googly moogly. I got the same thing. 1/2 for y. Okay, so my ordered pair, again, was 5/4, comma, 1/2. All right, and I should get the same answer for all three of these. As one of these answers doesn't match, means I did something wrong. So for my explanation, I've got two choices here, because graphing was terrible. Graphing didn't even get us close. Graphing, get out of here. We don't like you. Okay? So when it says which method was the best, either substitution or elimination. I would probably say substitution, because, I'll abbreviate a little bit, because the first equation was already solved for y. First equation was already solved. For y. Okay? And that's a great explanation. All right? If you want to say elimination, elimination was pretty good too. When we changed it into that standard form, we already had a negative 2x and a positive 2x. Okay? So things lined up pretty well. So you can make an argument for substitution. But as long as you don't pick graphing and you back up why you think it's the best, you should be okay.